And the floor is yours. Thank you.
Thank you so much, Shihad, and thank you again all for being with us today. And it's my pleasure to introduce today's speaker and to moderate the session. I'll start with the introduction of Professor George Saliba. So he's a professor of Arabic and Islamic Science at Columbia University, and then he's currently the founding director of the Farouk Jabre Center for Arabic and Islamic Sciences and Philosophy. He's the holder of the Khwarizmi Chair in Arabic and Islamic Science. He occupied the chair of Distinguished Senior Scholar at the Kluge Center, Library of the Congress, Carnegie, from 2019, I think, to 2009 to 2010. He studies the development of scientific ideas from late antiquity to early modern times, with special focus on the transmission of astronomical and mathematical ideas from the Islamic world to the Renaissance Europe. So, and that's during the 15th and 16th century. He received the History of Astronomy Prize from the Kuwait Foundation for the Advancement of Science in 1996, and the History of Science Prize given by the Third World Academy of Science in 93. And now I'll switch to introduce my colleague, Dr. Ahmed Al-Hilani. He's an assistant research professor at the chemistry department. He received his PhD in organic chemistry from Université Paris Sud in France. He recently studied philosophy and got his master's degree working on critical theory. He's passionate about both chemistry and philosophy, and hence his work on the history of scientific knowledge in medieval Arabic and Islamic culture. So, and today he's gonna share with us his experimental work on glass coloring following Jabir Ibn Hayyan treatise. And today's presentation is going to be a two-part presentation, and the title is entitled Deciphering Ancient Text in a Clean Glass Coloring from Cuneiform Tablets to the Jabirian Corpus. So we'll start with Professor Saliba and then switch gears and move on to the experimental part with Ahmed. So in this presentation, Professor Saliba will give us an overview of the work of Leo Oppenheim on glass and glassmaking in ancient Mesopotamia. He will also show us the making of glass in the lab in the 70s, how the making of glass in the lab in the 70s helped Oppenheim decipher the cuneiform text that contained instruction for glassmaking. And then Ahmed will share in that same spirit, in a sense, his experience to reproduce experiments mentioned in the book of the Hidden Pearl, Kitab Al-Durra Al-Maknuna, by Jabir Ibn Hayyan, recently discovered and assessed by the late Ahmed Al-Hassan. His work is an attempt to verify and authenticate the scientific knowledge and experimental spirit at work in the Jabirian Corpus. So I think now the floor is yours, Professor Saliba. You can start sharing screens if you want.
Okay, thank you very much, Sarah. Thank you very much, Jihad. I should only say by way of introductory remarks, when Jihad first suggested the topic to me about a year and a half or 2 years ago, and saying, look, do we have anything about glass from the historical material? And the first thing that came to my mind immediately is the memory of my days as a graduate student in comparative Semitic studies. And from those days, I remember there were all sorts of languages, like, for example, Akkadian languages, Ugaritic languages, which I studied all of those as part of the Semitic studies degree, and also languages of the Bible itself, the ancient Hebrew Bible. For those of you, by the way, who haven't looked at the Gesenius copy of the ancient Hebrew, you will find that every single Hebrew term is also comparatively drawn together with Aramaic, with Arabic, and so on. So the idea of trying to understand a language, especially languages that are way gone by now, trying to understand it and the tools of understanding those languages was always a puzzle for a graduate student. And I remember also my very first article that I ever published, I was still a student in 1973, was about this little flower that we called khuttaimi here in Lebanon, khutma, the classical term for it. And that very same flower appeared in a Ugaritic text. By the way, Ugaritic texts were only known up to the year 1200 BC. After that, the city of Ugarit disappeared, but we have these cuneiform tablets, and one of them actually gives a recipe of how to use that plant to cause reduction of fever and it cured the king at the time, which was King Karet. And to my surprise, as a graduate student, and to do a Ugaritic article, you had to use all of the other Semitic languages. So I was always puzzled by how does one decipher those texts, and sometimes just one word holds the decipherment of the whole passage. And I was proud that I actually managed to do it, and it was accepted. I was still a graduate student, so I'm still very proud of that article up till today. That when Jihad suggested that, so all of those memories came back, but then it was easy to remember also as a graduate student, also dabbling with Akkadian material, with ancient Semitic, Southern Arabic material, Ugaritic, as well as Aramaic, all of those still whirling in my mind on how to understand these languages. And then I remember the famous episode of Leo Oppenheim, who was at the Orient Institute in Chicago at the time. And I only heard an anecdote about it, that look at him, he solved the problem of 2 Akkadian words by subjecting the recipe in the Akkadian text to experimental work. And I've also heard at the time, I never have been able to verify it and certify it, that the Carnegie Museum of Glass, the Corning Museum of Glass, actually funded the research just because they were interested in the glass. And in fact, there was a long story how they attempted it for years and they didn't manage to produce glass until they got the ash from a plant that was locally grown in Mesopotamia. And sure enough, that particular ash produced the glass, and hence Oppenheim looked back at it and said, okay, now we understand the text. We can enter the items now in the famous Assyrian dictionary, which is still going on and gets published at the Orient Institute, but you need to verify that word before you can actually accept its meaning. So all of that rich story behind it allowed me to tell Jihad at the time, sure, we can talk about it as much as you want. And in fact, it is a pleasure to be with this group and to also have listened to the lectures so far that have been presented. They were extremely, extremely interesting. I'm very, very happy to have been put into this environment and hence to have learned a whole lot so far. Now, as far as I'm concerned, I want to take you on a little bit onto the actual presentation, and I want to forward it also by, I hope this is the one I want to share. I want to forward it by still in the same theme that I would like to talk about, is how to use ancient material or experimental material to actually decipher ancient texts. And hence, I start by this famous article that Leo Oppenheim published in 1973. By the way, all of those studies came into vogue after the Second World War. There were no such things to use or to actually experiment with the making of glass through cuneiform text until after the World War and the Second World War. And Oppenheim, I think at the time he had already joined the American Oriental Society, has moved into Chicago and so on. And at a dinner, and I will tell you a little bit about it, he actually published this note in the Journal for Glass Studies in 1973. It was just at the apex of several articles that were published at that time, dealing exactly with the issue of how cuneiform studies can actually be verified by experimental results, where we can actually get the results double verified. So in his article, in Oppenheim's speech, he says, progress in Assyriology research, I don't know how to get the speakers out of the way, meaning the participant, so I can get my screen. Is there a way to reduce the screen or no? I don't think it is easy to do that. No. Anyhow, he simply says he was already excited about the fact that he could actually use that tool to verify the reading of the text. And he says, we have only one of two ways to progress with the work on Assyriology, which, by the way, is the coined term at the time to mean both Babylonian and Assyrian cuneiform material. And he says the two ways are to actually hope that we find more tablets. By the way, for those of you who are not familiar with this thing, the most exciting thing that you can read for these cuneiform tablets is that you will begin, for example, in the tablet of Gilgamesh, in the tablet that speaks of the creation of the world. And all of those tablets, it's a long epic poem, and then you begin to read it, you get to the exciting point, and the tablet is broken. So we don't know what happened. So collecting bits and pieces of tablets, putting them together to make a coherent story is an enigma, and the Assyriologists actually have dealt with it for years. So in it, I think it's Oppenheim who says the research is to find more tablets so that we can supplement the fragments that we already have. And then he says, and this is another anecdote for those who know the inside stories of Assyriology, is to study the tablets that we already have. The story is there are two steps of digging any archaeological site. The first thing is to go to the site itself and take the shovel and dig the material out. But usually you are working under hard conditions, you are working on a limited time. So you collect the material that you will find and you bring it back to the funding institution, like University of Pennsylvania, Yale University, British Museum, and then all of this material is dumped in the basement of those institutions. The second stage of discovery is to dig in the basement. So to go into the material that you already have and to try to figure it out. And that's how this field progressed very nicely year after year. The documentary evidence we already have at hand has so far yielded for us remarkable results. For a historian of science, and by profession, I work as a historian of astronomy and mathematics as well. And I can say that the ancient Babylonian material has already yielded for us remarkable results. I'll give you some examples of what we have. And hence, all of these results were established in the early part of the 20th century, and I will demonstrate in what way their significance is very important. In the realm of the history of mathematics, I say the documentary evidence of cuneiform have already created a revolution in our understanding of that history, meaning the history of science in general, the history of mathematics in particular, history of astronomy, all of those keep changing every time you have a new tablet or you have a new interpretation of a tablet, so you get a new idea. The two examples I will give, for example, this famous tablet that exists still at Yale. It is in the Babylonian collection at Yale, number 7289. Sure enough, it has all of those remarkable cuneiform things and little signals. And at first they look very puzzling. You don't know what to make of it. But Assyriologists and people like Neugebauer, like Oppenheim, like Landsberger, and all of those have actually started. The very first step is to take these little signals here and transcribe them. Since the transcription is simply reproducing the image that is there by little pen drawing. Art historians know how to do this thing very elegantly, and then you end up with a double enigma. So you get at something that is just as perplexing as this one. Now, the third step is to begin to actually decipher every single one of them. And when you do that, you begin to find that these markers here, if you just count them, there are 1, 2, 3, and they are of a shape which is normally used for the number 10 that we see it here. For number 24 here, you see 2 10s and the additional 4s. And hence you can easily transcribe it now as the number 30. And then, of course, you do the same thing in here, and you end up with these numbers here. That's the one. And by the way, here we are dealing with what is called sexagesimal system. The sexagesimal system, the only place that we still use it, and use it a whole lot, is by telling time. Our morning times and our afternoon times are told by a clock that goes 60 units before it moves into the next. So every hour is 60 minutes, every minute is 60 seconds, and so on. This is the sexagesimal system that was invented in Mesopotamia first, and then of course it was supplanted for all other commercial reasons by the decimal system that came mostly from the Indian subcontinent. Now, once we know what these numbers are, it is a game now to try to interpret them. What the heck are they? And then if you look at them and you also learn how to separate units from decimal, not decimal from fractions, then you will be able to see that this tablet actually contains this set of numbers in here. The next step is to actually try to make sense of it. So if you take the side here as 30, which we have seen it from here is actually the number 30. And if I take this one, which also reads here as the number 1, and here the semicolon is what separates the units from the fractions. And hence, you read this number as 1 plus 24 over 60 plus 51 over 60 squared plus 10 over 60 cubed. So more or less, it is 1.5. It is very close to a half because 24 is close to the 30. But these fractions, you will see they gain a lot of significance. And then the last one is simply 42 as a unit and 25 as a fraction, 35 over 60 squared gives you that. Now, the intelligent archaeologists and deciphering of these cuneiform tablets simply managed to put this together. When you see 1, 24, 51, 10, which is a little bit more than a half, it is very close to what we call the square root of 2. That is a very good guess. You guess it at the very beginning because it's almost like 1.4, But to be absolutely certain that this is indeed the square root of 2, you take that square root of 2, multiply it by the side, which now it should give you the diameter of this, or diagonal of this square, which yields, it is just sheer calculations independent of what is written on the tablet. You get 42 units, 25 over 60, 35 over 60 squared, and bingo, it looks like this is exactly what this tablet is recording for us. The very first thing that does, it gives us a fantastic approximation of square root of 2, which, by the way, in the Greek traditions and in the ancient traditions was always approximated by whole numbers into fractions, meaning into ratios of numbers, and then tested, and then you don't actually, since square root of 2 is an irrational number, you are not going to get the final result that you can sign your name to it. However, modern computers are still computing the extension of this irrational number. That square root of 2 as well as the pi, which is another irrational number. All of those have puzzled people and they still go. But for us, it simply says that this approximation of square root 2, which is recorded here, actually gives us the very first occurrence of the approximation of square root of 2, which is a sophisticated management of how to express irrational numbers. And those irrational numbers, by the way, they gave trouble to mathematicians and they continue to give trouble. And now the higher the speed of the computers, the more you can do all of these things. And but now we can use that material to verify that we indeed have read this tablet correctly, all the signals on it are read, and the mathematic vigor of it proves that we have managed to solve that problem. The second type is this fantastic tablet, which, by the way, is still held at Columbia as a gift of Mr. Plimpton, who was at one point an art dealer in New York, and then he had some relationship to Columbia through the Board of Trustees and the likes. These rich people, by the way, they end up on the Board of Trustees. He donated this tablet to Columbia, which is still published and famously as the Plimpton 322. And the natural, this photograph I took myself, so you could see the natural shape of it is not easily decipherable, but when you turn it into black and white, it becomes a little bit easier. That same tablet was handled by Neugebauer in the 1930s when he was writing his famous collection of the astronomical cuneiform text in the 1930s. First it appeared in German, and then in English. And in that, he actually went and deciphered every single one and translated the numbers that are recorded on this tablet. And what did he find? He found that those numbers in here, they are actually sexagesimal numbers. And hence, you can actually try to manipulate those numbers and figure out what do they actually connote. And ended up saying that if you take, I will take this back and I'll take it back. If you take any of those, he noticed first that they are in columns, they are arranged in columns. And if you take those columns in the sequence, and then you end up, what up? Okay. You end up with these columns, and if you just, and which he did, he just marked them and tried to compute the relationships. And he found out that if you take the one column, suppose we call it L, and then the second column, call it B, and if you add the square of the first column to the square of the second, you are getting the square of the third. This is nothing but the Pythagorean right angle triangle. So he ended up establishing that here in Mesopotamia, we have already a sequence of 3 Pythagorean triplets, and their relationship is simply to put the numbers of several Pythagorean triangles of all sorts and shapes, and hence reduces computations later. And this tablet becomes like your regular, what do you call it? Like calculating machine. You come to this tablet and you have a regular triangle of this size. You end up calculating all the sides of the triangle, so you don't have to solve it every single time you encounter it. But that also meant something quite interesting. It meant that since the Plimpton tablet was dug up in Mesopotamia about the year 1800 BC, that's about 2,000 years before the age of, or what we call now, the AD era. And since we know that the Pythagorean triangles are derived specifically from the Pythagorean theorem, and the first occurrence of the Pythagorean theorem is in Euclid's elements of book 1, number 47. And that Euclid simply is in the first century or so, BC. And then when you compare the two, you begin to wonder what is going on. How did a Greek guy in the first century BC get to know of material that was already known in Mesopotamia about 1,000 years before? That was the urgent thing to actually begin to solve, that Neugebauer was motivated to do it in the 1930s. And of course, in that period, civilizations clashes, civilization, who is better civilization, who is über alles of the others. All of those questions were floating in Europe and were floating to say, our Greek civilization is superior because it is the source of everything else. And then all of a sudden you find that Mr. Euclid actually picked up the Pythagorean theorem. The numbers for it are already in Mesopotamia 1,000 years before. So you begin to doubt who is actually the indebtor, who is in debt to other civilizations, and so on. So that periodization of history began to be changed. But the most important part that we learned about these things is that, as I started this talk by saying, that the philological question as to what could these studies help us solve by way of this. Those people who did with this, they were quite aware of what they were doing, and the research that into this topic started, as was said by both Oppenheim and then by Brill after him. It started as a routine lexicographical investigation that we needed to read the text, and anything that helps us read the text was welcome. And now in the history of the glass of the ancient Near East, that Oppenheim joined in the American Oriental Society, and at a dinner they had down in North Carolina, they invited him to be the after dinner speaker. And in his presidential address, the poor guy, he was in Chapel Hill, and he knew that the members of the society had just had dinner and they are in no mood to go and study cuneiform tablets. So he tells his story in the following words. He says, I know that you are going to fall asleep, and I know it is a challenge to talk to people after dinner because it becomes very boring to do anything. He says, but I love to take up such a challenge. I'm going to try to interest you in a search for the meaning of two Akkadian words, both apparently rather uninteresting, which has led to unexpected results, meaning we can use them. And the two words actually are earthly Paku, they had no idea what it meant, and the second word was Meku, and both of them are sitting to be actually entered into the Assyrian dictionary at Chicago Oriental Institute, and he wanted to tell them how did they come to actually solve the problems of those two words. He goes on to say in here is that one particular part of the text describes the preparation of material called zuku. Again, they didn't know what zuku is. From the context, however, the general scheme seems to suggest that zuku is some form of an intermediate product that is prepared by reacting a mineral, which is here called imanaku, which also is, he believes that it is quartzite pebble with a husu and the ashes of the naga plant. If you use these, he says, then you end up producing what is described in the text. So it goes on to say, although the conditions and materials selected for our experiments were obviously arbitrary, the results certainly imply an important conclusion, namely that the zuku that is mentioned in the text and consequently the materials prepared from it is in the later procedures truly are producing glass. So you have this in the context here to say that the only way they could actually verify that this zuku and the materials in the context that it is described is to test it in the lab and see if the lab actually produces glass as the recipe seems to imply in the text itself. And hence, experimentation becomes at this time, the verifier of what a philological study needs desperately. You don't need to go to a comparative, another Semitic language to figure it out, because then you actually get all sorts of suggestions and they don't work. But the lab is the final verifier. And when you produce glass with the recipes, you actually can establish that you read your text correctly. So this is the spirit, I think, with which I will stop and conclude my part of it a little bit by recapping, to say here we found in the lab another dictionary, so to speak, another tool that helps us decipher the language. And in the same way, when Zuku and the other Akkadian terms were subjected to the experimentation at the Koning Museum for glass and did indeed produce glass, then the entry into the Assyrian dictionary was verified, and that's how progress was made in the studying of the language. Similar motivation has driven my colleague Ahmed Al-Hilani to actually subject another text to similar kind of procedures, but I will let him tell his story, and then I will just exit, I think, from. I will end my show and hand over to him, whereby I hoped, no, I didn't mean to exit from the scene altogether. Oops.
I think, Ahmed, you can attempt screen sharing, even if Dr. Saliba is still sharing.
While I am exiting, I don't think I'm forcing you to exit. So you can actually do it this way, but I will try to see how I can regain my, oops.
Thank you, Dr. Saliba. Sarah, can you see my slides?
Yeah, they're on.
Okay. So thank you, Sarah, for the introduction. Good afternoon, ladies and gentlemen. It's a pleasure to be in this series, and it's a very big challenge to talk or present after the eloquent.
Sorry, Ahmed, I'm interrupting you because this is still Dr. Saliba's presentation, though it's your.
No, I can move the slide. I think it's a big challenge to present after the eloquent George Saliba, but I'll promise to do my best to give you the same flavor of reasoning in my work. So today I'm talking about experiments on glass coloring that we did in the lab following recipes written by Jabir Ibn Hayyan in the 8th century. Before I jump into my slides, I want to thank Jihad, Hiba, Sarah, and all the other organizers of the series. I want to express my deep gratitude to Dr. George Saliba and Dr. Nader Al-Bizri and Ms. Nadine Masarani for giving me the opportunity to work on the history of chemistry, and Dr. Najat Saliba for hosting the work in her lab, and Mr. Yusuf Jukmara for helping in the slides. So Jabir Ibn Hayyan thought to have lived in the 8th century and died probably between 806 and 816 AD, just before the reign of Al-Ma'mun, where we had this great school of translating Greek and Syriac texts, Bayt al-Hikmah. So Jabir Ibn Hayyan lived in that period. He's no doubt the most famous Arabic chemist in history, and we modern Arabic chemists would love to have 1% of his reputation. And I insist, Jabir was a chemist, not an alchemist, because simply alchemy is a Latinization of the Arabic word alchimia. So we start playing with the philology a little bit. So alchemia is better translated as chemistry, and it has an Arabic origin, the verb kama. We say kama al-shay, ay satarahu wa ghattah. He is hiding something. It also has a relation with al-kama'a, truffles in English. Again, al-kama'a is a tuber plant like potato that's hidden in the ground. So having a little bit of knowledge about chemistry role in that medieval ages, we know that this meaning fits with chemistry. Going in the medieval ages a little like a few centuries farther, we can see on the right hand of the slide a 15th century portrait of Jabir. Clearly in the figure we see Arabic garments, but the name is now not Jabir, it's Jabir. This problem now is not a Latinization of the Jabir name, it's something deeper called the Jibber Problem. And it's a philological problem, as I'll show in a minute. So the Jibber Problem can be said in few sentences. Some of the collection of treatises or procedures found in the Latin language in the medieval period, they then found like original Arabic text for those or Arabic parallels of those texts. And those texts were signed by the name Jibber. So they were attributed to unknown Latin chemists signing their works by the name Jibber to gain visibility for their work and benefit from his high reputation. However, the Jibber problem turned to be controversial because like it turned out to question the very existence of Jabir Ibn Hayyan, that those authors used his name to promote their work. The problem of Jabir's existence in history goes even farther in old texts, as we can see that Ibn Nadim is trying in his Fihrist to defend the very existence of Jabir ibn Hayyan, saying that Jabir did exist, his case is certain and famous. We also go and check writings by Abu Bakr al-Razi, a known Arabic scientist that worked on chemistry and medicine and have no doubt on his existence. And he used to quote Jabir, saying that our master Jabir ibn Hayyan said. So the Gerber problem is a profound problem, and it was fueled in the 19th century with a prominent German chemist and historian of chemistry known as Hermann Koppe. So Hermann Koppe's problem was that the Latin Jabirian text known as Summa Perfectionis Magistre, or the perfection of or the mastery of chemistry, they didn't have original Arabic text. And when he asked a philologist friend to check those texts, that friend like confirmed for him that they were not translated from Arabic text. So he concluded that they have nothing to deal with the Arabic Jabir ibn Hayyan. The problem continued on with Julius Ruska and his student Paul Krauss, that ended up analyzing the Jabirian corpus, saying that the connections between what's written in the corpus and the Shia Ismaili sect beliefs says that the corpus, this humongous corpus, the encyclopedic nature of this corpus could not be written by one person. So it's probably writings from like a group of authors that share some ideological or religious way of thinking. That's to say the Ismaili group. So Paul Krauss' hypothesis number one is that the corpus was written by a group of authors. And number two, the oldest part of this corpus should not date back more than the second half of the 9th century. Some other people exaggerate and say that all the corpus was written in the 10th century. Paul Krauss' reasoning here was that in the corpus itself, you find some references to Greek authors, as we shall see in a few slides, like Plato, Aristotle. You even find some knowledge and some Greek words in the text itself. And he was saying that there is no way Jabir would have access to those Greek texts, or even in their Syriac translation, before Bayt al-Hikmah was established in the first half of the 9th century. In fact, Sayyid Nu'man al-Haq, I'll come back to this in a minute. So Sayyid Nu'man al-Haq in 1994, trying to assess Paul Krauss' hypothesis, said that if we compare the Greek words that were used in the Jabirian corpus with those translated by Bayt al-Hikmah, or what's called as Ishaq bin Hunayn school, we can find a very big difference. For example, Aristotle's Physica was translated by Ishaq bin Hunayn to be as-sama' al-tabi'i, and we keep using the same word. However, Jabir translated this as as-sama' al-kiyani, and al-kiyan is a Syriac word, or Syriac word. Another example was, if you refer to a paragraph, a coherent paragraph or a piece of text, in Ishaq bin Hunayn's school, you find it as maqala. For Jabir, you find it as maymar. So the plural is mayamir. This is an excellent word, and we don't use it anymore. So for this, Jabir has two options. Either he knew Greek, and so he read the manuscripts in their original language, or he had access to some translations. We do know that Abu Ja'far al-Mansur, the second Abbasid Khalifa, our caliph, had some books translated from Greek. And even more, we know that Khalid ibn Yazid, the grandson of the first Umayyad caliph, has some alchemical treatises translated from Greek. So what appeared as Jabir's burials in Vienna in 1930 by Paul Krauss, giving a talk in a conference of Orientalists, saying that there is no Jabir ibn Hayyan, could be refuted if we reassess the text, and this is what Sayyid Nu'man al-Haq did. Sayyid Nu'man al-Haq also concluded that instead of spending energy and years and resources on this topic, let's focus on the critical assessment of the Jabirian work. In fact, we claim that our experimental work falls in this category. There is also another problem with Jabir. Whenever you talk about Jabir ibn Hayyan right now, people think of him as an allegoric, mystical personage that used to do like weird things that will never work in the lab. And he was like just wanting to turn all metals into gold, wanting to find this elixir that saves from all ailments, or find this universal solvent that will dissolve everything. But in fact, if we assess deeply the Jabirian corpus, we can find the practical setups and practical procedures like the one I'll show you later in this presentation. One of like the prominent examples here is what's called al-imbiq. Al-imbiq is a distillation process to distill what Jabir called the spirit of the material. So you heat the material, it turns into gas, and then it condenses back into the liquid form. And this is typically the modern principle of distillation, and every chemistry student have used this distillation setup. In fact, the debate on Jabir's legacy was fathered by one person, Marcellin Bertolli, a famous chemist and historian of chemistry, because he said that one does not encounter in the Arabic works of Jabir precise formulae for the preparation of anything. In fact, Bertolli was not an Arabist. He didn't know Arabic, so he used interpretation of translation from other people. Bertolli's hypothesis was refuted by Paul Krauss himself, saying that this is unintelligible nonsense. And also it was refuted by Jean-Eric Holmiard, that highly praised the experimental spirit in the Jabirian corpus. And Holmiard invites us that if we want to judge on Jabir, we should consider the intellectual background that he was used, that he lived in. For example, if we find some esoteric meanings or like agnostic meanings amalgamated with precise formulae and procedures, we should consider this within the general context of the science and philosophy of the time. So if we do this, Holmiard would say that the Jabir's importance to the history of chemistry is equal to that of Boyle and Lavoisier. So if Lavoisier is considered the father of modern chemistry, Jabir could be easily the father of ancient chemistry. And he even stressed that Jabir transformed alchemy into an experimental science. And this is what we will show in the coming slides. Before we start with our experimental work, I wanted to show this quote from Sir Fraser Studart, Nobel laureate of 2016. He quoted Jabir as the father of chemistry. And Jabir says that the first essential in chemistry, I think we'll take the pointer, sorry. So the first essential in chemistry is that you should perform practical work and conduct experiments. In Arabic, أن تكون دربا هو أن تكون عالما حقا. So you have to have this experimental spirit, and you have to have precise experiments to do in the lab. It's funny because Dr. Studart mentioned this, and like a few lines later, he cited Marcellin Bertolli that refuted this very idea. So the manuscript we're dealing with today is called Kitab Al-Durra Al-Maknuna, the Book of the Hidden Pearl, which is attributed to Jabir Ibn Hayyan and edited by Muhammad Ibn Maymun Ibn Imran Al-Himyari Al-Marrakeshi. This manuscript was found in the Arabic collection in the Bibliothèque Nationale de France, and it was recently found in the 90s. And it's interesting because applying what Jabir calls the principle of dispersion of knowledge, we can find citations like this. Like, he won't talk about glass coloring in one book, and he refers to Kitab Al-Durra Al-Maknuna. So he auto-cites his work so often. Ahmad Al-Hassan, passed away in 2012, was the scholar who assessed this manuscript, who found and assessed this manuscript, in fact, and translated into English. He was the founding director of the Institute for History of Arabic Science. So Ahmad Al-Hassan found in the collection, or what's called the Majmu'a in Arabic, Kitab Al-Durra Al-Maknuna, about glass coloring and gemstone and luster glass making. He also found other treatises. Interestingly enough, we found something called Kitab Musahhahat Aflaton, emendations of Plato. Jabir is known for this, like we find 10 Musahhahat in his corpus, and he also found some medical treatises and other chemical treatises, either directed to the Barmakide family or Fatimid Caliph in this case. So Ahmad Al-Hassan published a 4-part paper on this manuscript, and he published this on his website as well. I invite you to check on this website, the History of Science and Technology, because it's really very rich information on chemistry and on other topics of history of Arabic and Islamic science. So this Book of Hidden Pearl, or Kitab Al-Durra Al-Maknuna, it's number 36 in Fahrist of Ibn Nadim, and it's number 39 among the 112 books of Jabir. So Jabir has this habit of preparing catalogs of his work. So you can hear of like the book of 70, Kitab Al-Sab'in, the book of 500, Kitab Al-Khamsumia. It's just collection of treatises and works that he collected together. Also, he cites the Kitab Al-Durra Al-Maknuna in several places in his corpus. For example, in Maqala 28 of Kitab Al-Khawas Al-Kabir, he says that, and pour it in it, as we have mentioned, Kitab Al-Durra Al-Maknuna, and you will get what you like if God wills. Interestingly enough, in another Maqala, number 68, in the same book, he cites Kitab Al-Durra Al-Maknuna, and he ends by saying, know that this has no allegories or superfluities, as if he knew that Marcel and Bertolli will attack him on this point. So coming to the experimental work, I'm sorry, I hope I won't have like electricity cut off, but just in case, Sarah will share my slides and I'll continue from my phone. So for the experimental part, we wanted to make a kiln. So on the left side of the slide, this kiln was presented by Dr. Rehan in the first presentation of the series. We couldn't make anything fancy like this in the lab, so we had to either to do our own oven or to buy a commercial one. We had 2 attempts before we bought our commercial oven. The first one used gas, and it failed miserably. And the second one, we prepared an oven using a water heating resistance, and it exploded. So we ended up saying to the Farouk Jabre Center that we need an oven, and they paid for this, and they sponsored having this in our analytical lab. Also, we used for the experiment, some clay crucibles. Again, the picture to the left is from Dr. Rehan's presentation. We used the same ones as mentioned by Jabir. And as a first try, we put it in the oven and heated to 1500 degrees Celsius, and everything melted, not only the glass. Later on, we looked on the material, and it's interesting because sometimes we have material like the yellow vial here. It's called curcuma root. So we bought this from shops that sell spices and other stuff like that. We also have minerals that were hard to find in the Aldrich catalog. So we had to look for these in the mountains. And interestingly enough, this specific mineral here is called Marcazite, or the fool's gold. It looks like gold, but it's not. So Jabir won't be happy about this. And it's funny because my friend was asking me if this is gold or not. So I said, yes, this is what I'm looking for, and I need it for my work. And also sometimes he used like weird stuff like eggshells and things alike. Then we assessed the recipes. We went back to the Arabic original and to Dr. Al-Hassan's translation, and we classified those as feasible. So the green arrows indicates the experiments that could be done in the lab, and the red arrows are those that are not feasible either because we could not decipher the ingredients. Like, for example, Jabir used something called Dam al-Akhawain. We couldn't find this. Or it has something that could not be done in a controlled lab setting. We translated the terms. We checked Al-Hassan's translation, and sometimes we corrected it. So for example, green tutia, for us, it's iron sulfate, not zinc oxide. Rosakhtaj is copper scales. Usrub is lead, and it's still used in the Persian language with this meaning. And now I'm sharing with you like 3 examples of the experiments we did. So for example, in recipe 10, we wanted to prepare, or Jabir reported the preparation of a glass with asfar jayyid, good yellowness. So we added for 100 dirhams, around 300 grams of glass, 20 dirhams of litharge. Litharge, as I showed earlier, is tetraoxide of lead or a mixture of oxides. So when we heated this in the oven, that the result should be yellow, and that's exactly what we got. Then we tried to explain with our modern knowledge if the color is what's expected. And we actually found in several references that if you heat lead tetraoxide, it turns from orange into yellow. Next slide, please. Okay, this is another example. It's a bit lengthy and it has 2 parts. The first one, next slide, please.
Sure. I just lost, okay.
Okay, so it has 2 parts. The first one is mixing the material and pulverizing everything together. Here we're using glass and rosakhtaj, which is copper scales again, and green tutia. As I said earlier, for us, green tutia meant iron sulfate and not zinc oxide, as mentioned in the original assessment of the manuscript. So we mixed everything, and there is another part of this. So Jabir did something experimentally interesting that he irrigated the.
Oh, that's bad.
Without irrigation, and we found that it didn't change much the results. Next slide, please. So here we mixed everything. As you can see, we have the copper characteristic color, and we have the green color mixing with glass, and we got exactly what he said, the emerald-like green glass. Even when we did with irrigation, we get the same glass, but we got an explosion of several crucibles. So we stopped doing this. Now, if we want to build the puzzle and see why the color turned out to be dark green. This is a 101 Jabirian chemistry course. So if you have copper plus heat, you're getting cupric oxide, which is black, or cuprous oxide, which is red. You simply get oxidation because you're adding oxygen to the heated metal surface. Now, if you heat iron sulfide, you lose water, and it turns from light green into white. So those crystals have some water in them. So if they lose water, they turn out to be white. Now, if you continue heating, you get the ferric oxide, which is black, red, or brown. So if you think about it, like red, black, and black, red, and brown won't give you the red, green. But if you do something interesting here, if you do something interesting and take the sulfate out away from the iron and put it on the copper I mean, a chemical reaction is happening here, you get the blue color. Now we can imagine that if you have blue with black or red, you will have a mixture that probably give you the red, the emerald-like green glass. Next slide, please. Sarah?
Yeah, I'm losing, I don't know why.
Like we have two more slides. So the third recipe is interesting because we have a small philological problem here to solve. So we mixed 100 dirhams of glass. By the way, we used a specific type of glass called the Fetter glass, but later on we figured out that we can use our Windows glass and it worked perfectly. So we added 30 dirhams of lead and 6 dirhams of copper acetate and borax. Next, please. Okay, so we mixed the material here and we got a very interesting color, which is yellow with a dark hue. It's not purple. Again, we tried to build the puzzle why we got this dark blue color. And we figured out that if we have lead tetroxide and we heat it, we get the yellow as in the first recipe. But if we have cupric oxide and we heat it, we're probably losing one acetate, copper acetate, sorry, and we heat it, we're probably losing one acetate, getting dark green, plus copper oxide as we have oxidation all the time. And lead acetate, if we have this transmetallation of the ligand between the two metals, we will have a white powder. So probably dark green plus yellow plus red give you this dark blue color. But the recipe and the translation of Ahmad El-Hassan says that farfiri, what Jabir calls farfir, should be purple. Next, please. So we went back into dictionaries and checked what farfir means in the old Arabic text. So it means a spectrum of colors from purple to indigo. So our results show that it's probably indigo. It's this dark blue characteristic indigo color. And it was interesting also to note that farfir came from Tyre. And there is a philosopher known as Farfir Al-Aphrodisi of Tyre, Porphyry of Tyre, because he was like his garments were always in this characteristic color. For us, it's indigo, not purple. So to recap it all, our work definitely helped in refuting the Marcellin Bertolli hypothesis that there is no specific experimental recipes in the Jabirian corpus. And probably if reassessment of the whole Jabirian corpus take place and compare the results, the experimental results of those work, like we did here, for example, we take colored glass and we compare it to some assessment of samples found in archaeological sites, we can verify the historical existence of Jabir Ibn Hayyan, keeping in mind that Jabir used to auto-cite his works. So if we find an auto-citation of Kitab Al-Durra Al-Maknuna in a book that has no doubt, that we have no doubt it belongs to Jabir, like Krauss saved some pieces saying that these are authentic to Jabir, like Kitab Al-Rahma, then we could solve the other part of the Jibber problem about the very existence of Jabir Ibn Hayyan. Overall, our work is an empirical crediting to the experimental spirit in the Jabirian corpus. Thank you for your attention.
Thank you, Ahmed, and thank you, Dr. Saliba, for the very nice talk and the walkthrough for us in science. And it was a very, very interesting journey from the cuneiforms all the way to the Jabirian corpus. I'll first ask the audience if they have questions. They can raise their hands or they can write their questions down in the chat, and I'll be happy to read them out and or give them their give them roles in the live chat, in the live question session. Yes, there's a question from Amelia. You can unmute yourself, please.
Hi, can you hear me?
Yeah.
Yeah, we hear
you. Okay, I'm sorry for the road work behind me. It's New Jersey, so it's road work land. I thought these lectures were so beautiful, and I'm coming from a non-scientific background, and so of course I was more able to connect with poetry that the science was coming through, like tears. In the second lecture, there was Jabir had said, you stir and it should be clear like tears, and everything ended with if God wills. And I was wondering how that affected the experimental process, and if it was sometimes something that Professor Al-Hani had to lean on in order to figure out if you were following the right instructions. Did you have to lean on the poetry to understand how loyal you were being to the instructions?
So that's a very interesting question. But in fact, in this very specific manuscript, Kitab Al-Durra Al-Maknuna, the book of the hidden pearl, you don't find this poetic tone, because it's very practical. It's like you're having a modern book of experiments, and you're just applying this. It just ends by saying like, if God wills. But the experiment is very specific. You have the material, you have the exact amount, and you just try it. That's it. So you don't have like to interpret any poetic tone in the text.
Ahmed, there's a question for you from Thilo Raren. Can you share with us your view on the difference between colored glass and precious stones in terms of value, spiritual or economic?
Oh, so I know that Jabir has a specific way of staining the gemstones, and it's also mentioned in this Kitab Al-Durra Al-Maknuna. It works by diffusion, I guess. But on the spiritual level, the difference between both, I didn't dig into this. Economic level at that time, I guess the gemstones were like of a higher value. I don't know if I answered that question.
No, there's a clarification to follow up. So we often talk about faking gemstones. Is that the case there too? Or is it more equal regardless of the origin?
What's that? Sorry. Sorry, so the question is that, was there like any recipe of faking gemstones? I guess. Yeah, that's... In the second part of Ahmad Al-Hassan paper, he's talking about coloring gemstones. And some of them, they are not authentic.
Again, there's a follow-up question on the previous one. So we see faking as negative today, but is that a modern concept?
I guess, yes. Because there's an interesting point about this, like Paul Krauss and his mentor used to say that all what's written in the Jabirian Corpus is forgeries. They were copying older manuscripts and like just translating a little bit. But Ptolemy refuted this and says that even this is very interesting by itself, because it's transmission of knowledge from generation to generation. So similarly, I say that even this faking of gemstones is very interesting from a chemistry point of view. And all this negativity about it is just a modern concept.
Thank you, Ahmed.
I have a question.
Yes, please, Emma.
Thank you, Dr. Hellani, for the talk on Jabir. I have one question concerning the historicity of Jabir. as one author for all these treatises. You seem very confident about it. So my question is, what kind of evidence do you have that Jabir Ibn Hayyan is one historical author, or let's say the only author of all the Jabirian corpus?
So obviously we couldn't verify this from our experimental work, but like what I mentioned is a book of Sayyid Nu'man al-Haq. He has a chapter about this, and he was saying that if we analyze the relation of Jabir ibn Hayyan to, for example, the Shia Imam Ja'far al-Sadiq, who is a historical figure, and if we analyze also his relation to the Abbasid viziers, the Barmakites, again, another Ja'far, and also if we analyze the auto-citation of the works in the Jabirian corpus, we can deduce that no, this guy existed. Especially that the knowledge at that time of making glass and doing some industrial chemistry, what we call industrial chemistry right now, was something common in the area, especially in northern Syria and Iraq. So,
Ahmed, if I may follow up on Emma's question, I think if I got this right, it's what you've done is like you've proved that something or a recipe is put to work and it's experimented, but this does not prove Jabir's existence in any way.
Yeah, I totally agree.
May I add something?
Yeah, wait a minute.
I'm sorry, I don't know how to raise my hand.
I want just to follow up on Ahmed's answer concerning the cross-references in the Jabirian corpus, which you're absolutely right, are extremely numerous. They are, on the contrary, they would support the thesis of multiple authors, because you will find in those cross-references make it very difficult, for example, sometimes to establish like a chronology if it was one author, because you find references in two treatises, let's say, to each other. You see what I mean? This is one. For two, I think beyond any doubt, you have in the corpus not only just short references or words to Greek philosophy, but you have huge fragments. I have worked precisely on the Jabirian corpus and on parts on fragments found in the Kitab Al-Durra that were, and I have shown that they were fragments by, so these fragments were by Alexander of Aphrodisias in the translation of Abu Bishr Matta. Abu Bishr Matta lived in the 10th century. So no way that the Kitab al-Tasrif could go back to the early 9th or late 8th century. Having said that, I will not, I think we don't have also evidence to fully deny the historicity of Jabir, but I think it's difficult to support the thesis that there is one author for all these corpus. And here, there might, I mean, if you are interested in the topic, there is a thesis which seems to me quite balanced about it, which is by Pierre Laurie, favoring a writing of the corpus in what he calls in French peau d'oignon, meaning like an onion, you know, by how do you call it in English?
Like layers?
Exactly, layers. So you'll have authors who would look at previous texts and wrote and write others. It's still an open question, but that's why I mean, this is what I wanted to say. It seems difficult to me to really support the thesis of one author, which does not, I mean, does not make it less interesting. I mean, I don't see why it should be, wow, super important to have one author, because already, as you mentioned, the achievement of these experiments and of this also the experimental spirit. And I don't know where you read what you referred to Paul Krauss, because Paul Krauss don't belittle Jabir Ibn Hayyan in his...
No, not at all.
Yeah, he is, in my opinion...
I'm sorry if I gave this impression, but...
Yeah, go ahead.
But no, not at all. He highly value Jabir.
Exactly, yeah.
He just says what you just mentioned, that it's like a group of authors. But he keeps silent about the very existence of Jabir. So for now, if we take like an approach in between both, like everything written by Jabir as one idea, as one hypothesis, or it's a group of authors as another, we can have something in between. That Jabir existed, he seeded the thing, and then layers built on this.
Most probably, yeah.
Thank you.
Thank you again.
I have something to add in this context, because I think there is a historical problem as to the authenticity of these early authors. I am sorry to say, and I published this already, by the way, in the 2018, 2018 in the Ambix magazine, in which I actually reinstituted the historicity of Khalid ibn Yazid, who is earlier than Jabir. Because again, all of this mess was started, and I called it the mess of Ibn Khaldun. And also the translation of Ibn Khaldun into French. Again, the French people should know that. They do not distinguish between Arab as long and Arab as a person. And Ibn Khaldun, when he speaks of Khalid ibn Yazid in one section of his Muqaddimah, he is the one who initiated this mythology by saying that Khalid ibn Yazid could not have existed as a real person, and hence whatever is attributed to him must come from a later Khalid ibn Yazid, with the assumption is the following. He said that Khalid ibn Yazid, to be able to do things in alchemy, he must have known something of the basics of the philosophy and of the formation of the theory of what the elements do. Hence, he must have known of Aristotle, but Khalid was in the Jil, he used the term Jil al-A'rab, meaning he was still too early to actually be in the dweller of a city where you would come in contact with these other civilizations. Hence, it was Ibn Khaldun who actually stated that this Khalid ibn Yazid does not exist, so it must be a later person, and the books are attributed to him. Now, when we looked at the text, and I looked at it, and as I said, it is published in Ambix 2018. In it, Ibn Khaldun, few pages later, like about 100 pages, the Muqaddimah, by the way, is a huge work. Few pages later, when he comes to speak of Abd al-Malik ibn Marwan, he says this is the time when the governance of the Arab regime changed from the Badawa into the Mulk, meaning we have now kings and we have all sorts of new features. We are away from the Bedouin things and so on. He forgets that he had already said that this Khalid ibn Yazid, who was a contemporary, by the way, with Abd al-Malik ibn Marwan, and whose grandmother, grandmother, meaning Khalid ibn Yazid, his grandmother, the wife of Muawiyah himself, because it's Khalid ibn Yazid ibn Muawiyah. The wife of Muawiyah was of the Bedouin tribes, and she was actually a Kalbiya, and it was this woman, Maysoon, who composed the famous poetry, sitting in Damascus, making the poetry saying, I yearn for the desert life. I hate this kind of luxuries I am exposed to here in the domain and in the house of Muawiyah. Literally speaking, as if Bedouin life is generations back behind her. Khalid ibn Yazid is the grandson of this Maysoon, and hence 2 or 3 generations have gone beyond the level of the Bedouinism that Ibn Khaldun is talking about. But because the first encounter of Ibn Khaldun in the European languages was through the French translation, hence the term Arab and the language got confused with the person. And again, the speculation of Ibn Khaldun that this was still a time of nomadism, and hence it's impossible for them to get to know of knowledge that could have only been learned through the translation period, which also means that Ibn Khaldun also suggests that the translation period, of course, started in the Abbasid time. Thank you very much. Both of them wrong. Both suppositions are wrong. And now we know that we have a whole lot of translations that went on before the Abbasid times, and the focus on doing this only because of that has a whole history of Orientalist reinterpretation of our history. But when we find now the sources and we find the people with real names and with the historicity of their presence, I think it behooves us to actually go back and read the sources very carefully. You will find that it would be easy to establish a real connection between Khalid and Jabir, because also Jabir suggests that he has studied with Khalid, and Khalid, as far as I'm concerned, as I refer you again to the article in Ambix, and it is the year is 2018, and there I have all the documentation on how Ibn Khaldun started all this mess, and we are still living it all the way with Orientalist repetitions. Thank you very much.
Dr. Saliba,
thank you.
It is said that Khalid took his alchemical knowledge from Marionas, the monk, and I found in one reference that Jabir took some of his alchemical knowledge from a pupil of Marionas. I don't know if it's like...
I would not be surprised, by the way, but you see, if we open that Pandora's box as to when were these translations started, we hope, and we do, I hope at some point, we go back to study that these people, for example, even the time of Umar ibn Abdul Aziz, the Umayyad, also speaks of libraries belonging to the Umayyad palaces. And in these libraries, finding books that were the most glaring example of all of this. If we have to wait for the Abbasid times to get to know a little bit of the Greek material and hence incorporate it into then what do we do with the Mu'tazilites of Basra, who were there before Baghdad was even built, before Ma'mun was even born? And those people were iterating and discussing very sophisticated Greek material and translating, like the Kunnash of Aharon that was translated by Masar Jawai in Basra itself. And this is way before Baghdad was even established. So these kinds of figures, if we keep dismissing them because we believed Ibn Khaldun, one paragraph of Ibn Khaldun, which is already refuted by Ibn Khaldun himself to say that the time of Abd al-Malik is so far away from the Bedouin times, and hence now Mulk has started and established a whole dynasty after Abd al-Malik. All of this needs to be put on the table. We need to study it, look at these sources, and the best way to do it is to actually, the authenticity now of Jabir is in the lab. You produce the material as to the recipe, hence he is not a fiction anymore. He begins to be a human being who's giving us a recipe on how to produce.
Thank you, Professor Saliba, for the very informative answer to Emma's points. And we still have some questions in the chats and on a different note by Sunu, asking what are the texts that were referred to in this corpus in terms of distances, local and distant lands?
Is it meant in the corpus in general or in this majmua that was found in the BNF?
No, I think in the corpus in general, there was no reference to Al-Durra Al-Maknuna in particular.
No, there was references. I mentioned those in the presentation. I chose like a few citations of Al-Durra Al-Maknuna, and it was number 39 in the 112 books.
Yeah, no, I mean the other texts that were referred to. So other than the Durra Al-Maknuna.
I don't know. I'm sorry.
So we have no more questions in the chats. Jihad?
Yes, Sarah. I have some questions. First, I want to thank George for taking the time to give this very relevant introduction to Ahmed's work, which I was very excited to follow Ahmed's experiments, both with the manuscripts and in the lab. I should just add that the whole coming together of this segment of the series resulted from a wonderful discussion I had very early on with George, which was instrumental also in shaping our thinking about the series as a whole. So thank you again, George, for very insightful comments from your perspective on the field and on glass in particular. I had a question for you, George, as a historian of astronomy. Can you give us examples where attempts at reconstructing instruments was helpful in helping us understand their function for those who built them or used them? Can you give us examples in which simulations were also helpful in deciphering, some difficult texts on ancient or more relatively more recent Arab or Islamic astronomical works? Do you have examples of that?
The example that comes to mind is this jewel of production that is called the astrolabe. Most people don't even know how it works. But the actual mathematics that is implied in the construction of an astrolabe is a simple geometric theorem, which is called stereographic projection, which actually allows you to project the whole sphere onto a plane and be able to carry all your computations on a plane. Now, the construction of astrolabes, we know it from very early times. Actually, I have a record and I published a piece quoted by the same Nadim, the author of the Faris, in which he says that about the year 850 of our era, meaning early part of the Abbasid times, there was not only astrolabes were being constructed, there were schools of astrolabes. In particular, Ali ibn Isa was supposed to have had 2 or 3 students. One of them is called Khafif, of whose work we still have actually 2 actual pieces at the Oxford Museum of History of Science, and who also says that it is in that school of astrolabe making that a woman by the name of Ijliya, and she also was participating in the formation. So it was common knowledge, people like Nadim quoting in the 960s about people in the 850 who had the sources. And by the way, the more I read the Faris of Nadim, the more I tip my hat to this excellent historian of science who has been neglected for years and been thought of only as a biographer. He's not a biographer. He's also an analyst of the intellectual history of the period, and he is always right. Every time I double check him, he turns out to be very right. Now, of course, we have treatises written in extensio. The treatise, for example, that was written by Mu'ayyad al-Din al-Urdi in the 13th century, who was asked by Nasir al-Din al-Tusi during the Ilkhanate times after the invasion of the Mongols to build the instruments for the famous observatory in Maragha, which is in north of Tabriz in the area of northwest Iran now. In that, Urdi gives us a full detailed treatise of how each instrument is to be built, and how it can actually produce the results, how to use it, and so on. Unfortunately for us, we don't have to recap all of this. This same treatise was read by people who worked in the Samarkand Observatory in the 15th century and actually tried to duplicate all of the instruments that were at Maragha, that were designed by this Mu'ayyaddin al-Urdi, was an engineer himself, who designed it all. And that same treatise finally surfaced down in India, especially in the 17th and 18th century, where the famous Jaipur Maharaja built also what is in the Indian tradition, they refer to it, that Maharaja actually built about 3 or 4 observatories built on specifically the treatise of Urdi. Those instruments, meaning that the masonry tools, still are there. You can actually use them to carry the observations that were suggested that they would do. And much more than that, meaning the treatise is verified and it is already constructed. A visit to Jaipur Jantar Mantar, or to the one that is in New Delhi, or the one that is in, but the funny question comes, if one observatory worked very well, why do you have to duplicate and build 5 of them? But the Indian excesses, I think, of Maharaja to show the power, to show the extension, and in every Indian city, he actually, about 4 or 5 of them, he built an observatory. And those are good functioning tools. They don't have to look like our modern instruments. Of course, they are limited to the questions. If you have the instrument, it is what you ask of the instrument is the essential question that you want. Ptolemy had the same instruments as the Ma'mun astronomers, but Ptolemy asked his instruments to observe the position of the sun when the sun reaches the summer solstice, and to mark the date when it reaches the solstice. It is only the Ma'mun astronomers who actually suggested that as a strategy of observation, this is the wrong one, because you cannot really determine exactly when is the sun actually turning back and has reached the summer solstice or the winter solstice. So all of those were discussed already in the 9th century. People were critiquing, how do you observe? What are the mistakes? Where did the mistakes come from? And verifying. There is not a single parameter that we inherited from the Greek tradition that stayed untouched. All of them were reviewed, were re-examined, re-observed, and what we have after the 9th century is fresh new observations and fresh new astronomy, which we still carry till today. By the way, very few people know that the tilt of the Earth axis is 23 degrees and a half is due to the Ma'mun astronomers, meaning to the Abbasid astronomers, and not to the Greek astronomers who didn't think that it was 23 and a half, because he followed the wrong observational technique and ended up by saying that the tilt is 23 degrees and 51 minutes, where it is about half a degree more than the actual one. And the fact that we still use up till today the 23 degrees and a half is a testimony to the accuracy of the Ma'mun astronomers and not to the survival of the Greek number 2351. All of this is in the sources, but we need to actually put the sources back on the table, tell Ibn Khaldun to shut up for a while and stop being interpreted by the Orientalists, and to begin to actually read our sources fresh, and you will find fantastic results are awaiting for people to actually do good work. I'm sorry to say to Ibn Khaldun to shut up, but he has irritated me for more than 20 years now.
It's very obvious. There's another question for both of you, Professor Saliba and Hellani. So do you know of any reference to arsenic in any of the ancient texts?
I leave all of that to Ahmed, because if I touch arsenic, I know it is deadly. I wouldn't touch it.
It's the same for me. So as far as the Book of the Hidden Pearl is concerned, I don't think that he mentioned arsenic. And arsenic, it looks like silver color, but probably if we heat it, it loses its color, it gets transparent. So from a glass coloring perspective, it's not useful, but I don't know if other references mentioned arsenic.
Okay, so I think we have no more questions in the chats. If people want to
sorry, I think there is in the corpus, in the Jabirian corpus, a mention to arsenic, but don't remember the treatises.
Do you remember the book?
No. I don't, sorry.
Thank you.
Thank you. So if we have no more questions from the audience and no more comments, I think we can thank our speakers for the very, very nice presentations and the very thorough answers that they gave us for these challenging questions, to say the least, about Jabir's existence in the first place, which I think Ahmed had done a beautiful job of proving that one of the recipes, at least presented in the Jabirian corpus, has been put to experiment and been shown to be completely functional and producing real output. And it was a very nice late afternoon to have you in this third episode of our Broken Glass series. And up to the next, I think it's going to be next Tuesday with 2 more lectures from today's lecture, and the Broken Glass series will end. It was nice having you all with us since the beginning of the series up to now, and thank you for hanging till the end. Thank you all.
Thank you, Shahad, again.
Thank you, George.
Thank you,
everybody, for generously being with us, and Ahmed for a wonderful introduction to your work. Ya'tik al-afi.